Okay, good morning, everyone. So today we are going to discuss about the formative for the preparation of your summative on Monday next week. And for those who have not downloaded the paper, please download it first in our Google Chat so that you can follow the explanation. First of all, you will have here the SC for criterion A and criterion D. So what you are going to have later in the summative is criterion A and D. So please do read this TSC because when reading the TSC, you can imagine what the question looks like and how we assess your summative. Okay, let's start for number one. Okay, everybody look at number one right now. A rescue helicopter is dispatched to help the stranded hikers. So helicopter want to help hikers. Yeah. And the hikers is located at the coordinate 4.7 and the rescue base is 16.9. Okay, so helicopter wants to help the hikers who is stranded, and then the hikers located in the coordinate 4.7. So this is the hikers age, yeah? And then the helicopter want to bring the hikers to the rescue base. Or the helicopter go from rescue base. Yeah, but the distance is from rescue base to the hikers. The rescue base is, let's make it B, yeah, coordinate B, 16,19. So the pilots want to determine the total distance. So this is the keyword, everyone, total distance. Okay, so if you don't really understand about the problem here, find the keyword. The keyword here is total distance. Oh, we want to find the distance then. So referring to the formula, finding the distance, okay, we have 2 points in here, H and B. So we are going to find the total distance helicopter must travel to reach the hikers. So helicopter go from the base to get the hikers. Okay, so the distance from H to B or B to H are the same. So it doesn't matter. The answer will be the same. HB or BH, up to you. So let's find the distance between H and B. So we have the square root, the formula is square root of x2 minus x1 square plus y2 minus y1 square. Okay, so let's identify what is x2, x1, y2, y1. So one of the coordinate must be x1, y1. So let's make h x1, y1. And the b as x2, y2. You can switch actually, yeah, up to you. For example, you want to have the hiker as x2, y2 is okay. All right. And then for the base as x1, y1, it doesn't matter. Yeah, if we switch, doesn't matter. Okay. Now let's subtract. We have 16. I change to the blue first. 16 minus 4. And then we square it. And then plus y2 is, what is this? y2. We have 19. So 19 minus 7. And we square it. And then let's calculate everyone. We have 16 minus 4 is 12. So we have 12 square plus 19 minus 7, also 12. So we have square root of 144 plus 144. And anyway, you will have calculator during your summative, so you can just calculate it easily. So you have square root of 288. And in calculator, you will have 12 square root of 2. But put a decimal, yeah, everyone, by pressing, what's the calculator? S to D here, S to D. So press S to D, then you will have the decimal 16.96 something, so 7. Okay, let's make as a habit to change it to three significant figures because 1, 2, 3. After 9, we have 7. So 7 here makes 9 into 10. So it's become 17 then point 0. So three significant figure. What's the unit here? We don't have units, so just a unit. All right, so that's how you answer this question. Next, number 2. Additionally, the pilot decides to do a quick equipment check at a designated checkpoint located at the halfway. So this is the keyword, everyone, halfway. Okay, pilot decide to have a quick check in the halfway point between the base and the hikers. This is the key information. Yeah, halfway between the base and hikers. Find the coordinate of the midpoint between rescue base and the hikers. So finding midpoint, the formula, yeah. So midpoint between B and H and B. All right. So the formula was what? The average, yeah, of the x-axis and the average of the y-axis. So let's try to write down first, yeah, the H coordinate. Last time was what? I think 4,7. And then the B is like 16,9, right? I just take this information from the question in question number one because this question number one and two are related. Okay. Um, the formula to find the midpoint first is just the average of the x-axis for the x1 plus x2 divided by 2. This is for the x coordinate, comma. Now for the y coordinate, we put y2 plus y1 or y1 plus y2, yeah, same thing. Okay, divided by 2. All right, so let's just change the uh, variable here. So let's decide. This is x1, y1, x2, y2. Maybe you ask how to decide which one x1, y1, which one x2, y2. Again, this is up to you. You can switch anyway. I put x1, y1 here as 4,7, but you can choose this as x2, y2. It doesn't matter. And the other one, I choose x2, y2, and you can choose this as x1, y1. It doesn't matter. But something you cannot do is you make 4,7 here, x1, y2. Cannot, yeah? So x1 will be paired with y1, x2 will be paired with y2. So it must be consistent like that. Okay, so let's try to put it there. We have x1 is 4, so 4 plus 16 divided by 2, comma 19 plus 7 divided by 2. Or, yeah, 19. Or 7 plus 19, up to you, yeah? The same thing anyway. Okay, and the answer will be 20 divided by 2, comma, we have 26 divided by 2. Okay, so we have 10, comma, 13. All right, so this is the coordinate of the midpoint. Next, question number 3. A lighthouse stand on a cliff. So we have a lighthouse, we have a cliff, stand on a cliff, shining its light toward its light toward a boat in the ocean. The light beam makes 55-degree angle. Okay, let's make the lighthouse first. We have lighthouse, make it vertical here. This is lighthouse, everyone. And the lighthouse has a light, of course. It's shining toward a boat in the ocean. So let's make this one as a red there. This is one, and oceans. We have blue oceans. Use blue line. And then the boat is in the ocean. Yeah, let's make a boat here. Maybe somewhere. This is the boat. Yeah. And then the light beams, the lighthouse stand, and then shining light toward a boat. So we have light toward a boat, light toward any direction, but this one toward the boat. Okay, this light beam, yeah, toward the boat. All right, and the light beam makes 55-degree angle with the water. This is the light beams. Okay, and then that's make 55 degree with the water. Water is blue there, right? That's the water. So this one 55 degrees. Again, the lighthouse is 20 meters above the sea level. Oh, this one's the lighthouse is here. This is the lighthouse. It's about 20 meters above the sea level. Oh, stand on the cliff. So this is the cliff, yeah, everyone. It's the cliff. So the cliff is 20 meter, and the lighthouse there 20 meter above. So this is 20 meters then. Okay, assuming the light beam travel in a straight line, of course, light travel in a straight line. How far is the boat from the top of the lighthouse? How far? So the boat from the top of the lighthouse. So we try to find the distance between the boat and the top of the lighthouse. So we try to find this x there, the distance of the light. Okay, so we use trigonometry. We have 55 here. So the 20 here because it's in front of 55 degrees. So this is the opposite. And the x here because the x in front of 90 degrees. So this is the hypotenuse. Hypotenuse and opposite, we use yeah, sine. So we are going to use sine 55 then equals to opposite over hypotenuse, so 20 over x. And then we want to find the x, so switch x with the sine 55, balancing method, everyone, transposition. So 20 divided by sine 55. Okay, so let the calculators do its job. Calculate. Let's calculate. We have 24.42. Let's make it three significant figure. So the x will be 24.4 meter. Okay, so that's the distance between the boat and the lighthouse. Okay, let's move on to question number 4. A submarine start at position A and move to position B underwater. Okay, find the total distance. Okay, the keyword here is finding the distance. Yeah, A to B. But we have three numbers here. Yes, this is the distance in 3D context, yeah, three-dimensional context. So the formula is still the same, don't worry. We have AB, so the distance between AB. Yeah, we still use square root, but we have three variables now. Just use 3 then. We have x1 plus, x2 minus x1, yeah. x2 minus x1 square, okay, plus y2 minus y1 square. Now, last time we had this, but since we have three variables, three coordinates, x, y, and z, so let's put the z now. Just add one more, very simple. No need to confuse, yeah? So we have z2 minus z1, and then we square. Okay, let's put the numbers there. Let's decide what is x1, x2, x3. So again, this x1, y1, z1. So this again up to you. I want to make this x1, y1, z1. This is x2, y2, and z2. Okay, and then we change the letter now. X2 is 10. So yeah, let's just change it. We have 10 minus 4 square plus the y. Here's 3y2 is 3 minus, this will be careful, minus negative 2. Minus with minus become plus later on, yeah, and then square plus z2 is negative 4 minus 5, and then we square. Okay, and we have 10 minus 4 is 6, so 6 square. 3 minus minus 2, so this one become plus, yeah. Okay, so 3 plus 2 is 5, so plus 5 square. And then plus negative 5, negative 4, we have negative 9, and then we square it. Anyway, negative, when we square, it's become positive, right? And it doesn't matter. Okay, so we have 36 plus 25, and then minus 9 square is minus 9 times minus 9, so we have 81. Positive, yeah? become positive. So negative 9, when we square it, it's become positive. Why pi? Because negative 9, you multiply by negative 9. Negative multiplied by negative, we got positive. Okay, let's let the calculator do its job. Okay, calculate. Add them. We have 142, I think. And then 142 is 11.916. Yeah, and then round it to three significant figure. Make it as habit, everyone. Three significant figures. So 1, 2, 3. So we stop at 9. After 9, we have 1. So it will be 11.9. Yeah, and what is the unit? We don't have units, so just write units. Okay, that's it. That's number 4. Okay, if you want to take notes, just pause the video and then continue to the next question. Let's continue the next question, everyone. Number 5, a drone is flying while being tethered to the ground with a cable. Okay, so we have drone, we have cable. So let's imagine this is the drone tethered with a cable. The cable is 8.5 meters long and the horizontal distance. Okay, let's make a cable first. Maybe like this. Okay, let's make a ground first. Okay, this one more or less like this. Yeah, that's the drone. So we have the cable ping. Yeah. The cable is 8.5 meters long, 8.5 meters long, and the horizontal distance from the drone position to the point where the cable is anchored. Oh, we have anchored, so let's make this one is the anchored. Anchor. Okay. And that's the anchor of the cable, that's the drone, and we have the horizontal distance. Here, horizontal distance from the drone position to the point where the cable is anchored. To the point, this is the anchor point, yeah? When the cable is anchored. The horizontal distance. Horizontal distance is mean like this. Okay, we have drone on the top, right? We have anchor on the bottom. And the distance is like diagonal. But if we talk about horizontal distance, you just simply make horizontal line. Okay, right. Up until the anchor. So the horizontal line here is what we are talking about. Okay, yeah, the horizontal distance from the drone positions to the point where the cable is anchored is 7.2. So this is 7.2, 7.2 meters. And when we project it on the ground, so actually the ground here is 7.2 also, right? It's like a rectangle there. We just project it on the ground. So we have there 8.5, we have 7.2. 8.5 is the cable length. 7.2 here is the horizontal distance from the drone to the anchor. Okay, and the drone operator wants to determine the angle theta. What is theta here? Is the angle between the cable and the ground. So we have ground, we have cable, so the theta is here. Okay, it's time for you to find the theta. So we have here 7.2 is the adjacent, right? And 8.5 here is the hypotenuse. How do you know about hypotenuse? Because it's in front of 90-degree angle. Hypotenuse. And this is opposite, yeah? We don't use opposite because we don't have the measurement. There is no measurement there. We only have 7.2, which is the adjacent, and 8.5 is the hypotenuse. Adjacent and hypotenuse, which one we use, everyone? Kah, yeah? Cosine there. So we have cos theta equals to adjacent over hypotenuse, or 7.2 divided by 8.5. 7.2. Okay, so to find theta, we use the special button in the calculator we press Shift button. Okay, so when we press Shift button, you will have cos inverse. Okay, to find theta, you have cos inverse, and then you write the fraction here, 7.2 divided by 8.5. So you will get the answer. Let the calculator work. So we have 32.106. Round it again, everyone, to the significant figure. We have 32.1 degree. Okay, so that is the theta. That's for number 5. Let's move on to question number 6. Question number 6. A warehouse manager is setting up a large rectangular store container to store grain. So we have rectangular storage. Rectangular storage is like a cuboid. Let's draw a cuboid first. Because it's storage, so it's a 3D, yeah? Storage. So it's 3D. Okay. Wait, let me make it better. Okay, yeah, it's better, but it's not straight. Okay. Nah, this one. Okay, this is the rectangular storage container to store grain. Okay, the container has a volume of 12,000 liters. And when we talk about liters here, unfortunately, our units for the length are in centimeter. So we need to convert first the liter into centimeter cube. But luckily in here, we are given the hint that 1 liter is equals to 1,000 centimeter. 1 liter, 1,000 centimeter. It means 12, 12,000. How many centimeter cube? Yeah. So 12,000 is the volume, right? So volume is 12,000 liters. So we multiply then, because 1 liter is 1,000 centimeter cube, so multiply by 1,000. So simply we just add the number of zeros. So we have 12,000,000,000. We have 12 million centimeter cube. Okay, that's the volume. But we are not finding the volume, of course, right? It's given here. The base of the container has the length 150, so this is 150 centimeter. The width is 80 centimeter. Calculate the height of the container. Oh, our goal is to find the height of the container when we have the volume of 12 million centimeter cube. So let's put it in the centimeter for the final answer later on. Okay, so the volume of the cuboid is just length times width times height. Okay, so we have 12 million for the volume, and the length is 150, the width is 80 times 80, and then times x. Yeah, let's don't use x yet, just don't want to mix up with the multiply sign. So let's make it height, h. Okay, multiplied by the h then. All right, so to find h, use balancing method or transposition. So h equals to is all multiplication. So you divide by 150 and multiply by 80 then. So 12 million divided by 150 and then times 80. Or maybe calculate first, like. I don't want to make you confused later on. 150 times 80, everyone. Let's calculate. 150 times 80 is what? Yeah, we have 12,000. Okay, times h. So h will be just 12 million divided by 12,000. And the answer is, we cancel the zeros. Yeah, so we have 1,000 centimeter. Okay, so that's the height of the cuboid. That's it. That's question number 6. Let's move on to question number 7. Okay, number 7, a photographer is standing 280 meters away from the base. All right. The tower look up at the top. Okay, so we have a photographer standing. Yeah, the distance from photographer from the base of a tall tower and look up at the top. So this photographer looking at the tall tower and looking up at the top. So let's make the tall tower first. Photographer, yeah, standing 280. So let's make the tall tower first. Okay, here's the tall tower. And then the photographer, let's make the ground first. This is the ground. And then we have the photographer. Yeah, here, photographer standing. And the distance from the tower is 280 meters, right? So we have 280 meters away from the base of the tall tower. Okay. And look up at the top. So this photographer look at the top here. Okay. Um, the elevation, the angle of elevation from the photographer's eyes to the top tower is 40 degrees. So angle of elevation and angle of depression is the angle that created from the line that goes up and the horizontal line, right? That's for elevation. So, and the depression is the line that goes down and the horizontal line. So the keyword here is with the horizontal line. So when we talk about the elevation angle of the photographer's eye to the top of the tower, so we need to make the horizontal line here. Okay, this horizontal line. Okay, so that is so the elevation angle of elevation will be this theta. Yeah, the angle that's going up and with the horizontal line. That's the angle of elevation. The angle of elevation is not theta. Yeah, it's like given here. It's a 40 degrees. So we have 40 degree here. Calculate the height of the tower if the height of the photographer's eyes from the ground is 1.5. So the distance from here to there, from the eyes to the ground, everyone, is 1.5 meters. Okay, so it means this is also 1.5 meters. So our goal is to find the height of the tower. So let's find the x here. And then after that, we add it with, we add the x by 1.5. So that's the height of the tower. Okay, we have 280 meters. It means this one also 280 meters, which is the projection there. All right, and we have this 40 degree. And let's identify the x here is the opposite, yeah, because it's opposite to 40 degree. And the 280 meters is the adjacent. Okay, adjacent and opposite, we can use TOA, tangent. So we have tangent 40 equals to opposite over adjacent. So x over 280. Okay, so to find x, we just multiply tangent 40 with 280. So 280 times tangent 40. Okay, so what is the x then? Calculator. Okay, we have 234.95. Okay, should we round it to three significant figure? Not yet, everyone, because we haven't found the height of the tower. Yeah, we round at the end. Okay, if we haven't finished, just use the long decimal numbers. Okay, so we need to add first by 1.5. So let's conclusion, the height of the tower is 234.95 plus 1.5, yeah, and the answer will be 236.45. And this is the time when we round in We round to three significant figure. 236. After 6, we have 4, so it's still 236 meters. So that is the height of the tower. Okay, that's question number 7. Let's move on to the next question, number 8. Okay, number 8. Two hikers start walking from the same campsite. Okay, so this one about the direction. So I want you to know first. That's going up is the north, down is south, right is east, left is west. Okay, so that's the direction. And two hikers start walking from the same campsite, the same starting point at the same time. One hikers walk to east, so let's start in here. So one walk to east, for right then, how many kilometer? Oh, we have speed here, 5 kilometer per hour. 5 kilometer per hour. So at the end later, how many hours then? Because we need to find the distance in here. While the other hikers walk to south 3 kilometer per hour. To south 3 kilometer per hour, like this. Okay, how far apart they are after 4 hours? Now we have the time, we have the speed. Yeah. So if you remember, the speed formula is speed equals to distance over time, right? So if you want to find distance, it means you multiply speed by time. Speed multiplied by time, so we have the distance. And in here, we have the speed and the time, so we just simply multiply them together to have the distance. Yeah? Logically, 5 kilometer per hours, it means you will reach 5 kilometer in 1 hour. It means if for hour, yeah, 5 kilometers, 1 hour, second hour, 10 kilometers, the third is 15, the fourth is 20, so 5 times 4, right? So yeah, speed multiplied by the time. 5 times 4, we have 20, so 20 kilometer, and to south is 3 kilometer per hour, so we have 4 hours, means 3 multiplied by 4. 3 multiplied by 4 is 12 kilometer. Okay, and then the question is how far apart are they after 4 hours, right? So that's the question. We are going to find out the distance here. Okay, so pretty straightforward. I think it looks like right angle triangle. And we have the measurement. We need to find the hypotenuse. Okay, let's use Pythagoras theorem then. So the Pythagoras theorem says that c square, the hypotenuse, yeah, since the hypotenuse equals to a square plus b square. The hypotenuse is the longest side, everyone. So if you want to find the hypotenuse, you need to add the square of the other side. Yeah, you don't subtract if you want to find the hypotenuse. So a square plus b square. So we have c square is equals to a is 20, so 20 square plus 12 square. So we still have square there. Let's remove the square by square root both of the side. So we have c equals to square root of 20 square, which is, what is that? 20 square is 400. 12 squared is 144. Okay, 400 plus 144 is 544, yeah, correct. And the answer in calculator will be, okay, 23.324. Right, so let's round it to three significant figures. So we have 23.3. So kilometers. That is the distance between these two people. Okay, that's question number 8. Let's go to question number 9, which is the last question. All right, the ice cream shop is designing a large decorative cone to place outside the store. The cone has a circular base. Okay, so the shape we know first, yeah, it's a cone. Imagine the cone first. All right, the cone has a circular base with a radius of 6. So every time you have question like this, try to draw it. Sketch it first so that you can have the pictures will be easier for you to see where is the location of the radius, and you put it there 6 meters and etc. Yeah. So the whole problem in your summative will be word problem. Yeah. So everything will be word problem because the summative will be talking about criterion A and criterion D, which we combine. It means you are going to have all related to real word problem. So every single question there will be word problem. Okay, please try to sketch first. So let's sketch the cone. We have this, and then let's make the cone. Aduh. Okay, that's the cone. And we have the radius is 6, so let's make the radius 6 there. Okay, the radius is 6. And then we have the 6, yeah. The height of the cone is 8 meters. So we have the height of the cone there, which is 8 meters. Okay, the height and the base, 90 degrees. Okay, before painting the cone, the shop's owner needs to determine the total surface area of the cone, including both the curved surface and the circular base, both the curve and the base circular, yeah, the circle base. Find the total surface of the area, surface area of the cone. Okay, simple. So we need to find the area of the base, which is circle, pi r square, and we need to find the curved surface area, which is pi rs. Right. So the total surface area, I just want to write TSA, yeah, total surface area. The formula of the base is circle, which is pi r square, and then plus the curved surface area, which is pi rs. Okay, that's it. But unfortunately, in here, we don't have the s, right? The slant height. Okay, but we have 8 and 6 there, and this looks like a right angle triangle. So we can use Pythagoras theorem. Okay, s here is the hypotenuse, right? Because it's in front of 90-degree angle. Look at that. So we can see s here is as a c. Yeah, so we have c square equals to a square plus b square. This is Pythagoras theorem. So we have s square equals to the a and b. You can choose either between 6 and 8. Yeah, it doesn't matter. Because so we have like 8 square, for example, plus 6 square. So s square equals to 64 plus 36. And when we add them together, so I just want to remove the square, yeah? So s equals to square root of them. So 64 plus 36 is 100, right? So 100 is 10. So that is the s. S is equals to 10. Let's just put that into our formula. So we have pi times r squared. The r is 6, so 6 square. Okay, plus pi times the r, which is 6, times the s. Where's the s, which is 10. Okay, 6 squared is 36, so we have 36 pi, plus 6 times 10 is 60, so we have 60 times pi. Yeah, let's use calculator. 36 pi plus 60 pi. Yeah, so there will be 301.59. That is the answer. Let's round it to 3 significant figure. Everyone, please round to 3 significant figure later in the summative, yeah? So that's one part of the assessment. Make it 3 significant figures. So the answer will be, we need only 3 left, the first 3 numbers, and after 1 we have 5. So make it 302. And what's the unit here? We have meter, so because talking about area, so it will be meter square. Okay, so that is the end of the question of this formative. Okay, good luck for your summative, everyone. See you later. Bye-bye.